So thanks a lot for inviting me for this great, hybrid meetings. So today I'm going to talk about the sex differences in autophagy and mTOR inhibitions, as I would say that is a new frontier in anti-aging interventions. So first of all, I think everyone knows about that sex is probably one of the biggest difference in human populations. But I would like to make clear to say that when we talk about sex, it's basically we refer to biological sex. So it's referred to sex chromosomes, sex hormones, and everything related to those things in our bodies. And of course, when we also have some social interaction, when we are most likely to talk about gender. So that is more like a spectrum, believe or not. But that's not the main focus today. So in 2001, so basically 20 years ago, Carl Venter, so I guess many of us already know him, is that he actually is, when the human genomic project is almost finished, he mentioned that we are all essentially identical twins because based on the sequencing. But I will try to argue of that because is partially true if we only look into one sex. For example, if we compare one woman to another one, yes, there's a 99.9% similarity between those two because the genomic sequencing. But if we compare male and females, or like let's say the woman and man, actually due to women have XX and men have XY, so we have we are not that identical. If we actually trying to compare women between women and men, we are more or less actually have the same distance between human to chimpanzee. So this is more likely you can imagine that is a huge difference between those two sexes. So that's the reason why we often observe a lot of sex differences, not only in development, but also in lifespan, as you can see on the left-hand side. And so if we go back to the history from the 1820s, so it's almost 200 years ago, we already see that the women are always long-lived than men. So that is something not only related to modern society, but if we look into the time that the people are in the famine, so the people are starving, or we're in a very healthy situation, we always see this situation happens. But more importantly, the sex differences is not only happen in lifespan, we also observe a lot in health. For instance, that we know a lot of disease, for instance, autoimmune diseases, that is a female bias, but something related to cancer is more male bias. So that is something we are very interested to answer the underlying mechanism why there's such a differences in those perspectives. Yeah, so nowadays, I think some of our speaker already mentioned this before, is that nowadays we know that there are several hallmarks of aging, and we're trying to develop interventions to challenge them, for instance, like a genetic intervention, drug intervention, and so on. And at the end, when we're trying to target those hallmarks of aging and trying to conquer or even prevent age-related phenotype and diseases. So that is obviously our dream or our aim to do that. But when we combine those interventions with this sex differences lens, we always see that there's a lot of differences because of sex differences. So for instance, if we just look into the very global pictures, so we just count how many drugs have a sex differences response. And at the moment, we only saw that there's no clinical relevance to sex differences. This drug is only less than half of the drugs. So that means the other half is more or less have a sex differences or even sex specific things. And more importantly, when we talk about drug protection or anti-aging drugs, for instance. We also saw that a lot of well-known neuroprotective candidates, including rapamycin, argabosa, and so on. This is something we observe, at least in mice, that there's always sex differences in response in terms of lifespan extensions. So that's the reason we want to answer why is that. And I also want to show you one chart before I jump into my data. I will also want to mention that this sex differences is not only happen in drugs, but also the other lifespan extending intervention, including genetics and also dietary restrictions. So that means there's actually something not because of the pharmacodynamic or pharmacokinetics. It's more basic differences that probably in our genome or in our body, let's say like that. Yeah, so my main focus actually is trying to targeting autophagy and mTOR pathway. So those two hallmarks are well connected, as you can see on the chart of the hallmark of aging, but also the signal pathway. So the good thing is that we have a very powerful tool for here is rapamycin. So I guess most of us already know that rapamycin is somehow can extend lifespan in multiple model organisms, including mice. So rapamycin is a very specific inhibitor to inhibit mTOR C1 when we use it shorten. And when we manipulate mTOR C1, it will also hit the autophagy later on. So that is these two hallmarks is something we're trying to just answer if there's something actually is also sex differences. And yeah, so that is already I showed you that mentioned before that there's something that we already know that rapamycin can extend the lifespan in multiple organisms. But nowadays, based on the current data, we also know that it can also benefit health span, at least for dogs and elderly, so at least in the short term. But we don't know that whether the rapamycin can also extend their lifespan. So that is something obviously is interesting to pursue. But today I'm going to talk about some of my work recently published on Nature Aging. So as I mentioned before, that rapamycin it shows sex differences in terms of lifespan extension in mice. We also saw that rapamycin also have strong sex differences in fruit flies. So as I show you, and here you can see that rapamycin can extend fruit fly females the lifespan significantly, so more or less 10% in red line. And if we compare to the males, so that is the blue line. So there's nothing actually. The male just don't respond to rapamycin at all, and we don't know why. So first of all, we would like to test if male actually eat rapamycin, because first of all, we would like to know if there's some pharmacokinetic or dynamics ongoing. So we did a Western blot and trying to test phospho-S6 kinase, so one of the peptides, to measure mTOR C1, whether it responds to rapamycin or not. And interestingly, when we look into our data, basically we don't see any sex differences in terms of responses. So that means rapamycin is well received by both sexes. So we don't know why. So, and then we're trying to test another branch beneath the mTOR C1, because we know S6 kinase is not going to do something at that for sex differences. So that means maybe autophagy does play an important role. And that's the reason we look into autophagy. So we use a Western blot and also lyso tracker. And I hope everyone can see that there's an interesting pattern as I show you. First of all, female responds to rapamycin in terms of autophagy. So you see that the ATG8A2 and also lyso tracker increase significantly after rapamycin treatment in the female guts. And in male just have a higher expression level or higher autophagy activity compared to female, as you can see, more or less to the same level as the rapamycin treated females. But more importantly, as I would like to tell you here, is that the male does not respond to rapamycin treatment in this case, because there's not going to increase the autophagy activity further in this way. So that means that actually there's some interesting interaction between sex and the rapamycin treatment on autophagy. Yeah, so we want to develop causality, because obviously when we look into when we do scientific finding, we need to define what is the causality and what is just observation or just something to the same direction by chance. So we try to we develop genetic manipulation, trying to knock down the inhibit autophagy level only in the gut. So as you can see, suppressing autophagy in the gut can shorten the lifespan and deteriorate gut health only in males. So that means autophagy actually are quite important, and the level of autophagy, because there's difference between male and female. So because female has a very high autophagy, so when you trying to knock it down, it will shorten the male lifespan, but not going to do something for female, because a female already have a very relatively low basal autophagy levels. Yeah, so so we're trying to go further to answer what's going on in this case. So it was very lucky, because before this paper comes out, I got another finding in female, and we found that in the female intestine we have a very interesting finding that mTOR can actually go through the epigenetic regulation, so change the histone protein level in nucleus and then activate BCHS, so we call blue cheese actually in flies. And blue cheese is a novel autophagy related protein that can activate autophagy, and at the end rapamycin can go through the histone path to activate blue cheese and improve intestinal health and also extend the lifespan. So that's the reason we're trying to look into this signal pathway in our male and female settings. And we saw that similar to the autophagy level differences, we also saw in the histone H3, H4, and also blue cheese pattern. So namely that female responds to rapamycin, but not in males. So that is the main conclusion in this case. So now we know that, okay, that's something maybe interesting to pursue, because obviously we like to develop new interventions for female or for male. In this case, actually for male, because the female responds to rapamycin quite well, but male is not very well. And we're trying to say if there is something we can do on the gut specifically, and then we can improve the male health as well. So take the advantage for the fruit flies, we can actually switch the sexual identity only in the gut, as I show you here. And then at the end of the day, we can create a chimera that the feminized male flies or masculinized female flies, but only happen in the gut. So for the fly, that's on outside, you don't see anything. So they are very healthy, very, very normal. So that is something interesting to tell you. And when we switch the sex identity in the gut, we saw that the histone protein level is just go with the sex in the gut, but not the organelle sex. But more importantly, the autophagy, as you can see here, is also go with the gut sex. So that means that if we just change the sex in the gut locally, this autophagy and histone signal pathway that in the intestine, it will also change based on the sex the sexual identity. But for the whole body, there's nothing significant change their behavior and so on. But of course, we would like to see if there's something changed in the gut, it would be also benefit for the general. So we ran the lifespan for those flies. So here I show you that's feminized males compared to the normal males. And as you can see that, so feminized male, it responds to rapamycin by the lifespan extension, which is very interesting. And also, it also responds to the gut health and the intestinal integrity, and also the stem cell, the proliferation. So everything related to gut health and also to the general lifespan, it kind of like a switch after you feminize the male gut. And on the opposite way, we are trying to also masculinize the female guts. So in this case, when we masculinize the female guts, we got lifespan extension dramatically compared to the control. And this lifespan extension is more or less around 10%, is to the same level as the normal females treated with rapamycin. So that means when we masculinize the male guts, when we masculinize the female gut, the female will gain the same benefit as rapamycin does in lifespan extension, but also in the intestinal dysplasia, so this tumor formation, but also integrity and stem cell proliferation as well. So that means actually there's something we can use maybe in the future, that so we don't even need to use rapamycin, but just trying to switch the sexual identity in the gut or microbiome. So I'm already showed you some flight data, but of course, when we talk about the anti-aging interventions to human for applications and possibility, we have to, obviously we have to also look into mammals, because that is something, probably more close to human, right? So first of all, I would like to show you that's the data from the IDP program. So it's from Richard Miller in 2014. So at that moment, they already saw that female, in the given doses of rapamycin treatment, female response far more better than males. And that is something. And since we observe some interesting phenotype in light gut, so we want to look into, there's something worth to also check in the mice gut. So first of all, we know that there's called leaky gut syndrome, or something related to inflammation for the gut. And we do know that that is not a healthy situation, but often happen in the elderly. And it will just, the gut junction just damage, and then a lot of bacteria, if there's some unhealthy bacteria just get into the blood to cause chronic inflammation. So that is something at the end of the day will make you unhealthy. So that's the key point. And first of all, we look into the mice gut. So we saw that the percentage of intact tight junction decreased with age. So that is something is not surprising. We know that it's just similar to human or the other, to the fruit flies. So the gut, when they age, obviously it's just like a pipe. There's a lot of place damage, and some of the places even have some leakiness. And the funny thing is that when we look into, when we treat the rapamycin with mice, and then we look into their percentage of intact tight junctions. So if you compare the rapamycin continuous female, so that's the red line, I hope you can see that, compared to control. So I would say that rapamycin can attenuate this age-related effect. So that means rapamycin can make you have a more good or better intact tight junctions. So that is in female case. But in males, we do not see this, we see the trend, but not as strong as rapamycin treatment. So that's probably something related to the lifespans differences, which is Richard Miller showed you in his paper. And most importantly, when we look into Salmonella and these are bacterial infections, because we know that when we have destroyed gut or something like that, the Salmonella or the other unhealthy bacteria will just trying to get into your body and trying to increase inflammation. So in this case, we saw that very striking sex differences or sex interactions between sex and rapamycin. So first of all, rapamycin in females, rapamycin treatment can reduce the Salmonella infection in this case. And in males, male actually seems like they have a healthier gut compared to females. And rapamycin is not going to, further improve the gut health, similar to what we observe in fruit flies. And then we also look into the blood, because at the end of the day, all these bacteria, when they leaky through the gut, they will get into the blood and then just go into the other organs to create the inflammation, right? So we look into one of this LBP, so as a kind of like a marker to respond to bacteria, and we saw this very striking that rapamycin in female. First of all, in female, rapamycin can reduce LBP, so that means rapamycin can alleviate chronic inflammation in old mice. But in males, you can see that control male already have a better or lower LBP level. So that means male are always healthier in general, and rapamycin continuous treatment is not going to do something else. So that's those data are trying to summarize in the right-hand side is that we have a leaky gut. And so when we get old, we have a leaky gut. And so this LPS went through the bacteria went through the gut barrier to get into the blood. And then we'll create the LPS LVP complex to create the inflammation, and also trying to trigger some insulin resistance and so on, the other stuff. And obviously at the end you will have an unhealthy situation. And rapamycin can alleviate this. But more importantly, I would also like to show you that in our animal model, at least in fruit flies and also in mice, we observe this very strong interaction between sex and rapamycin treatment. So that means that there's something we should actually consider in the future, that when we use a rapamycin, we might only benefit half of the population, and the other half, maybe we can try to do the sex switch manipulation or something, and modify drugs that can benefit males. So that is the main thing I would like to tell you, and acknowledgement, obviously, thanks my supervisor, Linda Patrick, and my collaborator, Jennifer Regan and Richard Miller. And so that is the funding I would like to just say. But since I still want to use still time to also try to show you something more interesting, and actually is our startup project that's supported by the Max Planck Innovation. So because I already mentioned there's a lot of good things that we can actually use a fruit fly to do. So we have actually have a startup to use the fruit fly to do those screening, mainly focus on the longevity or age-related diseases. And I'm not going to tell you too much, but at least I can tell you our technique are able to screen a lot of individual in a few seconds, and it can also well integrated into the existing pipeline to accelerate the drug discovery process. So that is something I would like to just show you. It's very cool. And we are here for you. And that is our leadership team, and also the support from our supervisor and also Max Planck Innovation. So in case you're interested for academic collaboration or something related to this project, please just contact me via my email, LinkedIn, or even WeChat if you are familiar with that. So thanks a lot, and that's my talk, and I would like to take any questions. Thank you.
Thank you so much, Yu-Xuan Lu, for your wonderful session. And have any questions to Yu-Xuan Lu, you can ask now, or you can write it down to his email address, or also you can write it down to our email address, longevityfederation@sciinohealth.com. So yeah, any questions to Yu-Xuan, you can ask now. Once again, thank you so much, Yu-Xuan Lu, for joining us today and giving your valuable session. It's a pleasure to have you at our conference.
Yeah, thank you. Yeah.
Yes, bye-bye.
Yeah, sure.
Can we see Peter Fedicho? Robert Conrad? Robert? Okay. Now we are going for an half an hour break. Then after the break, sessions will be resumed with Robert Conrad sessions. Yeah. Thank you. We can see someone join the conference with the name of administrator. So may I know who is? I just seen someone join with the name of administrator and MZ, sorry. So may I know who joined the conference? Because it's a bit difficult to understand the names MZ and administrator. So yeah, can administrator? Hello,
Hi, hello.
MZ. So MZ means what?
Y-
Like who joined the conference?
Hi, hello. Am
Yeah,
I
what's your
audible?
name? Yeah, it's audible.
Hi,
What's your name?
my name's Mahad. I have joined the conference. If you want me to change, I can change my name title as well. It's not a
Not
problem.
required. No, not required. Just want to know who joined the conference. And you just as joined the conference as a listener, right? Not like you have some session to present at a conference.
No, I don't.
Okay, then we are on break, so sessions will be resumed after break. Okay, MZ.
After the break.
Yeah, now we're on break because
Okay,
one of the
okay.
speaker didn't turn up for the conference, so we have forcefully have to
All
give.
right, all right. Can I? Will I be able to get the recordings of the previous sessions today because I couldn't
Definitely.
join it. Sorry.
So, so whose session you want to listen? So, what is the reason? Like, why you join the conference? You have someone to listen, or what?
Yeah, I wanted to listen to all the speakers, but I couldn't listen because I had meetings earlier in the day. But I just wanted to listen to all the speakers that
No
were presented
problem.
previously.
No problem. After the conference, of full program is recorded, including physical in person. So, yeah, online, all the
Right?
programs sessions are recorded. So we are going to upload all the recordings, all the sessions in our official YouTube channel, and we're going to email you as well. Okay.
Okay, perfect. That's great. Thank you.
Yeah. Thank you. Administrator, we have seen someone who joined with the name administrator. So request them to respond. Thank you so much for joining us, Robert Conrad, for On Time.
Hello, good afternoon.
Yes. The next section is from Robert Conrad. He's from Biolytic AG, Switzerland, and he's going to speak on data-driven longevity, harnessing the potential of actionable health data and revolutionizing preventive care. So I request Robert Conrad to take the screen and start the session now.
Wonderful. Thank you so much for having me. It's a pity I can't be with you in person. I would have loved to come, but I was on a multi-week travel marathon through different conferences, and my wife warned me that the kids are going to forget my names, and if there's one thing that's not good for longevity, it's if your wife is mad at you. So that's why I'm only here
That's a universal problem. No, nothing, doctor. Yeah, you can go ahead.
Perfect. So yeah, what I really love about these conferences is that there's always an amazing amount of smart people in the room. And it's amazing to have these conversations. And there's the saying that when you're the smartest person in the room, you're in the wrong room. And definitely every time I feel that at these conferences, I'm definitely not the smartest person, but I often ask myself, why did you guys even let me in? So it's really amazing to have all these interactions with all of you guys. And it's very humbling at times. And there's so much great research going on. There's so much great research in many different areas, in biology, in medicine, in chemistry, in molecular research and all this. And if there's one observation I can make is that sometimes it feels a little bit that there's a lot of search going on for, in a way, the magic bullet, right? Or the magic pill maybe is the better word. So that one pill that will extend our lifespan, extend our health span, that we just pop the pill, and then we can live 20, 30, or 50 years longer. And don't get me wrong, I think that's very important research, and we should definitely continue to do that. But what we also must not forget is that, in a way, we have this magic pill today already. And that's something that's sometimes it feels like, with all the excitement about these great developments, we seem to forget that. And what is a magic pill? If we think about one of the most common diseases that's massively decreased not only our lifespan, but also the quality of our life, it's cancer. And cancer, I'm sure everyone is in some way or form affected by cancer. I'm sure everyone in this room, whether virtually or physically, has had someone who's suffering from cancer, lost someone to cancer, maybe has been suffering from cancer yourself. And there was a study in the Lancet journal, which I'm sure you're familiar with. It's one of the most prestigious scientific medical journals, a while ago. And that study looked at what percentage of cancers can be avoided just with lifestyle. So they called it modifiable risk behavior. So what percentage of cancers can be avoided, which is not genetically or not through toxins in the environment, but just through lifestyle. And whenever I ask this question at conferences, what people's guess is, it ranges from maybe 2%, 3%, 5%, maybe 10%. But the quite shocking answer is that it's 44%. And I want you to really let that sink in, because while we're looking for this magic pill, while we're looking for the great solutions out there to make us keep longer, we could cure every second cancer essentially just through lifestyle, and we're still not doing it. And I find it always quite fascinating, but also quite shocking. And the question then becomes is, why are we not doing it? Why do we have that? And what even defines our health? And so there's several things I want to discuss. So first of all, why are we not doing it? It's we're creatures of habit, right? No one likes to change their lifestyle. No one likes to change how we live. We've always been doing the things we've been doing. So that's definitely one factor. But then we also need to look at what defines our health. And if we really radically simplify it, our health, and that of course is then directly linked to longevity, is essentially in two areas. I mean, we have our genetics, and we cannot change them, at least not for now. And we all know there's some interesting research going on around CRISPR and so on, but there's no practical way to really change our genes. So whatever we were born with, we have to live with. And with regards to genetics, there's two categories, I would say. So there's the mutations, where if you have something that's a mutation and it severely impacts health, you cannot change that. And no, that's this category. There's things like the BRCA genes for breast cancer, where you just, if you have that, then you're getting a high likelihood of developing that disease, and you cannot do anything about it. The good news is that if you're listening to this, then you're most likely to not have any of these really severe mutations, because otherwise you wouldn't be here, because most of these will then end your life earlier in your lifespan. But then there's the other 80%. The other 80% of our genes are genes that may negatively affect our health, also positively, potentially. But we can, up or down regulate them with our lifestyle. And so in that way, that's what I was saying is that's where our magic bullet really is. Because if we think about it, if we're honest to ourselves, what are the biggest impact factors on our health as we speak? It's essentially, it's 4 categories. It's how we eat. It's how we take care of our body, how we exercise. It's how we sleep, and it's how we take care of our mental health. I think these are the 4 big levers. And if you get those right, then you have a very good chance that even if you have genetics which are not ideal or might have some risk factors, you can influence a lot. And also these 4 big categories will dramatically help you in your longevity and in avoiding not only diseases like cancer, but also a lot of the chronic diseases that many of people around the globe are really suffering from. So so why is not everyone doing it, and why do we not all live an optimized life? And there's 2 reasons for it. And one I just mentioned before, it's creatures of habits. It's really hard to change our behaviors. But also, if we want to really optimize our health based on these various factors that we can influence, we need to understand a lot more about what's going on in our bodies. Because if we think about our health, there's several factors that we can impact, and what does the right diet mean? What does the right exercise mean? What does the right other factors mean? That's different for everyone in the room. And so while, of course, there's general recommendations about that we should all sleep enough, we should all eat a clean diet, and what precisely that is, and finding the optimal point to really optimize your health and longevity, that's different for all of us. And that's why we need data for. And I started a small company called Biolytica, and essentially we are in the field of health data. So we are focused on providing a solution for healthcare professionals. So our clients are typically longevity centers, preventive medicine institutions, high-end wellness, personalized wellness centers, and so on. And we help these institutions to really gather data about people in very different areas, from genomics, pharmacogenomics, epigenetic tests, biomarker tests, nutritional information, lifestyle information. And then based on this data, our platform allows them to really create hyper-personalized and hyper-optimized health and longevity journeys for their patients or for their clients, however you want to call it. And because data is a very, very boring field, and I don't want to get you to sleep at the second day of the conference in the afternoon, I want to quickly show you how using data can really look like in a practical application to make it a bit more understandable, and really show you the amazing effects that just understanding the right data points about someone can really have a massive impact on longevity. So allow me to quickly share my screen. And I hope this is going to work for you. Let me just get here. That's always the downside of doing things online. All right. Okay. So let me start with asking the question. We are essentially not living in a healthcare system. We're living in a sick care system, right? Because usually what we do is we don't support health and staying healthy. We support fixing issues. And I want to show you. I want to start a little my presentation with a little video that was recorded last year in Italy that really shows what's wrong with our healthcare systems. And that really shows why the approach that we're doing is wrong. And this video was secretly recorded, and the people in the video didn't know that they were recorded. So please don't share this video with anyone outside of this group. But yeah, let's get started. So yeah, this is me and my middle daughter back in Italy in one of those playgrounds, playfair thingies, and playing the game of whack-a-mole. But when I saw the video, I actually realized that that's a great representation of how we do healthcare today. Because in our healthcare systems, what we do is we wait for issues to pop up, to symptoms to pop up, and then we hit them with the next best thing. Typically, that's medications, pharmacology, and then we wait for the next thing to pop up, and then we hit that, and then we get side effects, and then we hit that, and then it's kind of, in a way, it's an endless game of playing whack-a-mole. And we believe there's a better way to do that. And besides the platform that we've built, we also work with people directly and help them to optimize their health. And I want to show you a case study of a real person that actually came to us a while ago and that we worked with. And I really want to show you how we use data to optimize that person's health and longevity and lifespan. So of course we changed the name, we changed the images, but the data that you see is real, and the data that you see is from our platform and from the interventions we did with that person. So let's call that person Bob, and Bob is like many of you in the room, right? He's very successful, family man, middle-aged, entrepreneur, very high energy person, and so Bob also has something, or has developed something over the years, which is called metabolic syndrome. And metabolic syndrome is not an acute disease. It's more like a cluster of different symptoms. It's fatigue, it's inability to focus, blood pressure, blood lipids out of whack, being pre-diabetic. And what metabolic syndrome does, it puts you at much greater risk late in life to develop things like cancer, develop things like diabetes, neurodegenerative diseases, and so on. So it's not something that kills you immediately, but definitely has a big negative impact on your longevity and on the quality of your life. And why this is so important to talk about metabolic syndrome, for example, is that 1 in 3 people statistically, so 1 in 3 people of everyone listening, either already has metabolic syndrome or will develop it along your life. So it's a disease that affects a lot of people. And so what's the typical, let's say, standard sick care system response to someone with metabolic syndrome? It's medications. Yeah, we need to put you on statins, we need to put you on antidiabetics and all these things. And that's exactly what happens with our person and with Bob. He was put on a variety of medications by his doctor, but then every time he went for checkup, things got worse. And the answer was, okay, we need to give you more medications, right? That's a typical answer that we get from the healthcare system, sick care systems. And of course, now with giving more medications, you get more side effects, and all the different wonderful things from issues with muscle wasting, liver issues, erectile dysfunctions for the gentleman in the room. So really, it's something that really negatively affects your life and impacts your healthy lifespan quite dramatically. So he said, look, I'm not even 50 years old. I don't want to be on medications for the rest of my life. Isn't there a better option? Isn't there an alternative way to approach this this disease that I have, this condition that I have? And luckily he knew someone from our clinical team. And then that person from our team talked to his doctors, and they said, look, we don't really believe in that, and we don't really believe in health optimization. We don't really believe it can do anything here, but we're going to give you 2 months to try out whatever you want to try out, and if that doesn't work, then it's back to more medications. So okay, challenge accepted. So how can we look at healthcare differently, and how can we use data to really impact healthcare? And there's different things. So first of all, typically this is how your doctor sees you. Like, you're essentially a bunch of lab values, and unless you're really in depth into the field and in medicine, it's really hard to be involved because most people don't understand what all these values mean. And that also makes it very hard to be involved in your personal health journey. So the first thing we can do, and the first thing we do, is we just take these values and visualize them differently, right? And make them more, let's say, understandable for people. And so what we could see in this specific case was that we were dealing with a person who had multiple issues at the same time. Blood lipids 3 times too high, chronic inflammation almost 10 times too high, blood pressure through the roof, very close to a cardiovascular event probably, issues with detox with his liver, almost twice as high, cholesterol was out of whack. So really we're talking about someone who was middle-aged, but was already chronically ill and was definitely steering towards serious health events in a matter of few years. And of course, that's not good for longevity. Then we need to look at, okay, the picture that we're getting from this data, is that just a singular instance, or is that something that's has developed over time. And what we could see, looking at old lab reports, analyzing them, is yes, that was something that was an ongoing problem. So there was not just a little hiccup because there was some underlying acute condition, but this was really something that it was clear that Bob was a chronically ill person. What else can we look at? I mean, typically what your doctor would look at is what kind of medications are you taking at the moment? What kind of medications have you been taking in the past? And then that's pretty much about it. So usually, as I told you, the typical answer from our sick care systems is giving you more medications and just doing more whack-a-mole with symptoms. But there's more that we can do, and there's more data that we can use to optimize your longevity. And one of the most important things is genetics, because everyone in this room, everyone who's listening, has a different genetic markup, has different genes, has different constellation of factors that will positively or negatively impact your health that we can optimize around. And so typically a raw genetic report looks something like that, and unless you're a geneticist, you really cannot do much with that information. But what we can do is we can use algorithms to take that information and group it, so to speak, alongst several different pathways. So we can look at what genes are affecting which areas. And what we could see for that person was that there were some genetic risk factors or high impact factors in the areas of inflammation, of detox, for example, of cholesterol, and a few others. That's very, very impactful, but what's other data that we can use? Other data that we can use is, of course, everyone is wearing wearable these days. I'm sure a lot of you are wearing the Oura Ring or wearing a smartwatch, and we can use that data to look at the lifestyle of people. We can look at their activity, we can look at their exercise patterns, we can look at their weight from smart scales, we can look at all different kinds of things. So we did that, and what we saw was that that person, Bob, was living a very sedentary lifestyle. So not enough movement, couch potato or office potato, however you want to call it. And there was just not enough movement in his day-to-day life. What's other data that we can look at? Of course, there's nutrition. And nutrition is, as we all know, diet is one of the biggest impact factors on anyone's health. But how do we track nutrition? That's really complicated, because you can ask people to do food journaling, but then again, that really will not. People won't do that. If you ever done a food journal, you do this exactly for 2 days, then you stop doing it. But everyone is wearing a phone in your pocket, and at least my generation, a lot of people are taking pictures of the food anyway after every meal for Instagram and so on. So we can use these images and then run algorithms over them and really see, okay, what are the how does the nutrition look like? And what we could see in that case was that we saw way too much sugar in the diet, way too many simple carbs, and overall a very unbalanced diet. Now, so what do you do with all the data? So in our platform, we can do several things. We can calculate aging clocks, which I'm sure you're familiar with, which gives us a hint about how much older or younger that person is biologically than versus chronologically. In that case, we could see that all the aging clocks showed that he was over his chronological age. But more importantly, what we can do is we can combine all the data sources together and get a fuller picture of someone's health, and showing us let's say the areas of, we always call it like the low-hanging fruits of your health, the areas where we can really start optimizing, because not only do we have a problem there, but also we can see that we can have the biggest impact with small lifestyle changes. And what we could see in the case of Bob was that there were some issues on the cellular level around inflammation or detox, around cardiovascular health, cholesterol, and some other areas. So we use this information, and that information can also give us, let's say, a lot of options on what we can do. And we can really start to truly personalize a health journey for that person. But based on what we knew, there's a multitude of things that we thought might be beneficial for that person to optimize his health and longevity. But of course, we all know we're creatures of habits, as I told you before, and no one is going to change 50 things at the same time. So we really needed to know what are the things that we're going to have the biggest impact based on all the data that we gathered before. And using all the data and using our platform, we really focused on 3 main areas, in the areas of inflammation, of cholesterol, and detoxification. Relatively easy and simple lifestyle changes that he was able to implement in his day-to-day habits. So we also changed his diet quite dramatically. Massively reducing carbs, going on a high-fat diet, very strictly, very dramatically. We made sure that he's training in the right way, which was right for his genetic type. So really moving him from a strength-based training, in this case, to a more endurance-based training, optimizing that. And then what impact did we have with that? Remember, the traditional doctors gave us 8 weeks to optimize. And the changes that we got with these personalized, hyper-personalized lifestyle optimizations were dramatic. So essentially, within just a few weeks, inflammation CRP reduced back to normal. We had triglycerides, blood lipids 3 times too high, stabilized after 5 to 6 weeks. Then we had fasting glucose, so he was pre-diabetic. That almost immediately stabilized once he was on a low-fat diet, high-fat diet, sorry. Liver values normalized within just a few weeks. So really, we were seeing dramatic changes in his health in a very short amount of time, just with the right data-driven, personalized longevity optimizations. And now the interesting thing is, moving forward in time, he still is keeping all his healthy values. He kept his lifestyle changes. He went from being a chronically ill person with massively reduced longevity to someone who's now basically off most of his medications he was taking before, enjoying life, lost a lot of weight, and really is someone where we could see that this personalized data-driven interventions is really something that was a great success and great help. So that's just one example on what data can do. And I just want to take the last few minutes to just address to one thing that I'm seeing over and over again, also at these conferences when I talk to people in the longevity field. It's amazing that we are a community that is really open to experimentation and self-experimentation. And you meet a lot of people that optimize their longevity. They take a lot of supplements. They take a lot of everything. But what I can see, and what we also can see in our day-to-day business, because we also have a clinical team who work with people directly, we often see people that actually are overdoing it quite a bit. So they're taking massive amounts of supplements, for example. And we had some cases where some of our doctors were seeing people coming in close to renal failure. So the kidneys almost close to giving up because they were taking 70, 80 supplements at the same time. Every time they read something in a book, they just started taking these supplements. And I just want to caution everyone that it's great to do self-experiment, but make sure that whatever you do, use data to your advantage. Don't just blindly take stuff just because someone mentioned it's good, because it might not be good specifically. And so what we always do is we tell people to first start from scratch, wash out everything, don't take anything for like 4 to 6 weeks. Then take a baseline, so measure your biomarkers. Get some data on yourself, see what your current diet, your current lifestyle will provide you with. And then if you see a need, then you can start adding supplements or adding certain molecules. And another word of warning as well, and I had a very interesting conversation with Brian Kennedy a few weeks back in Singapore. Also, be careful with the molecules that you hear about that might have a positive impact on things like the mTOR pathway, for example, because maybe taking one of these molecules may be beneficial, but if you take 2 or 3 at the same time that all target the same pathway, you might always go in the wrong direction, right? You might always downregulate something too much, whatever pathway it is. So what I'm trying to tell you is use data to your advantage, and really use data to measure yourself, retest yourself, and be very careful with interventions and be very data-driven with your interventions, because that will really tell you where you are in your health journey, and you should never do anything blindly. And I highly discourage anyone from taking dozens of supplements at the same time without really knowing how they work, how they impact themselves, and without really understanding the data that we have. Some final thoughts on data. I personally believe that data is incredibly beneficial, but for anyone who's maybe working with data, and there might be some people in the room that work with health data, that try to optimize longevity based on data, that maybe develop similar products and also similar apps in different fields. I think we need to be very conscious about how we use data, because with data we have 2 big areas of that are problematic, put it this way. One is the area of trust. A lot of people don't trust data. They believe that data can be abused. And that's a fair statement to make. That's a fair point, because data can be abused, yes, and we all know that data is being sold. There's lots of data points that I would not my insurance company to know about me, right? Because I might have some genetic issues or might have some other issues, and I wouldn't necessarily want my data to be floating around freely. So I think everyone who's dealing in the data field needs to be very conscious about that, and needs to be also very responsible about data. Because if we abuse data, and if we take advantage of data that's detrimental to others, and if we sell data, for example, we're just going to ruin the trust in data. We're just going to ruin the trust and the positive effects that I just showed you that data can have, and this way we're going to really negatively impact the whole industry. The second issue is around compliance. Of course, with trust comes all the issues around compliance. Data is a very boring, but also very complicated subject. We need to be very careful to follow all regulations if we're working in the fields, which are different, which are very complex around the globe. But I believe that these data regulations are not our enemy, they are our friends, because they help to gain trust. They help to make sure that data is not being abused. So while, of course, it's a pain in the butt, to deal with all these compliance issues and regulations, I believe it's a very useful thing, and it really helps to have a wider audience keep their trust in the positive effects of data, and really allows to create solutions and create services and create software and platform and so on, to really help us optimize our health and help us optimize our longevity. As a final word, is data always the right and only answer? Yes and no. So as you can imagine, I'm a big fan of data, because I'm seeing the positive effect it has on people's lives day to day. I'm seeing how much it can change people's lives. I'm seeing how much it can impact health and longevity when used correctly. I can really see how data is part of that magic bullet that we're looking for, how it can help us extend healthy lifespan by 10, 15, or even more years, just using it correctly. But it's not always the right answer. And we've seen cases. We had one case of someone coming into our clinic, or to our clinical team, who was obsessed with data. So he was tracking everything, had 3 different sleep trackers at the same time, a smart mattress, and then, whatever, the Oura Ring, and then another sleep tracking device. But he had sleeping issues. He couldn't sleep through the night. And he was obsessed with that. So every time he would wake up, he would immediately look at his stats and look at his different devices, and then, damn it, I should have gotten 23 more minutes of deep sleep and whatnot. And then he couldn't fall asleep over it, because he was so obsessed. So what we said was, in that case, look, you know what? Get rid of all the stuff. Get all of that stuff out of your bedroom. Forget about collecting data about yourself. Forget about your alarm clock. Just try to sleep. Just go to bed and wake up whenever you feel like it. Try to get back to your natural rhythm. And the interesting thing was, after a few months, his sleeping pattern has dramatically improved. He really has now good quality sleep, a right amount of sleep. And the solution in that case was to actually not use data, but to go back to instinct and the natural intelligence that nature has given us. So yeah, that's it for me for today. I believe that really data plays an important role in longevity. I believe that we can really use it to our beneficial effect. And if anyone is interested, then please feel free to contact me. Happy to answer all the questions that you might have, and I'm happy to jump on a call anytime. And let's work together to improve health and longevity. Any questions?
Thank you so much, Rob Conrad. So I request other attendees and speakers have any questions to Rob Conrad, you can